Hello everyone. So we are now looking at calculus part 2. So the calculus part 2 involves the finding the gradient at any point. So now how do you find the gradient at any point? So for you to find the gradient at any point, it is the first thing that you're supposed to do is differentiate. So as I said in my previous video, calculus differentiation can be used to find the gradient of any point of any given point on a curve. So as long as it has got x squared or x cubed or above, that's a curve. So we are going to say, for us to find the gradient at that point, we are going to say our solution will be, for y should be equal to x squared plus 1 over 6x. Then where we have x should be equal to 1. So we are going to say our dy over the x should be equal to the power multiplies that. So we have 2x raised to the power 2 minus 1. Then plus, we have this one, we are going to multiply 1 times 1 over 6x, we have 1 minus 1. Then we have 2 x, 2 minus 1 gives us 1, which is the same as 2x plus 1 over 6, because 1 minus 1 is equal to 0, of which any letter raised to the power 0 is equal to 1. So we have this one as our dy dx, or in other terms we can say the gradient function. So this gradient function will now help us to find the gradient at any point. Specifically for this one, we are finding the gradient at where x is equal to 1. So we are going to say our dy over dx should be equal to 2. Then we have x which is equal to 1 plus 1 over 6. So to work out this, we have 2 plus 1 over 6 should be equal to 6, 12 plus 1. So our gradient, which is our dy over dx should be equal to 13 over 6 as our answer. So this dy dx, for some of you who don't know, is the gradient. So if you're asked to say find the gradient, it's just dy dx at that point, which is 13 over 6. So the second thing that you might be given is, let's say for b, we have y should be equal to 1 over 2 x raised to the power 4 minus x, like that. Then we are told to say find the gradient at where x is equal to 2. So how do we find such a problem? So we are going to first differentiate to say dy over our dx should be equal to, we have 4. It is going to drop here, we have 4 times 1 over 2, then we have x raised to the power 4 minus 1, like that. Then minus, we have a 1 here when it drops, we have 1 by x raised to the power 1 minus 1, we are subtracting 1 from the power. So we have this and this will go, here we are going to remain with 2. So we have a 2, then x, 4 minus 1 gives us 3, then minus 1 minus 1 is 0, any letter raised to the power 0 is equal to 1. So we have this as the gradient function. If this is the gradient function, therefore dy dx at where x is equal to 2, we are going to say 2, we are going to substitute 2 for x, we have 2 cubed minus 1. So here we have 2 raised to the power 3 gives us 8. So we have 2 by 8 minus 1. So here we have 2 by 8 gives us 16 minus 1, which is equal to 15 as our dy over dx. So this is the gradient at that point. So remember always, the gradient function or dy dx can be used to find the gradient at any point on a given curve. Thank you very much for watching.